Okay, welcome to today's lesson. It's lesson 3.5 and we're solving quadratic equations. So a couple things that I want to go over first, just to make sure that you understand what you're being asked to do, is what does solving mean? And this is true in any question, whether you were looking at solving equations in grade 9 or in grade 10 or even next year in grade 12. So solving means that you need to find the value for x. Now I say x, but it's not always x. Most of the time we're using the variable x in our equations. But you're finding the unknown value in the equation. And if you look down near the bottom of the screen at example 1, we're trying to find the number that you can put in for x that makes the left side equal the right side, or makes that equation true. Now when you were in grade 9 and you were solving equations, there was no exponent on the x. So we moved the numbers to the one side and the x's to the other, and that told us the value for the x. But when I'm solving and there's an exponent on the x, I go through some different steps. So you might remember this from last year. The first step is always to set one side of the equation equal to 0. I always have to start that way. Then my second step, there's two different choices. So step 2 could be to factor the equation. This is usually our quicker method. I factor it, and then I set each factor equal to 0. At that point, it's going to look more like grade 9. I'm going to have something like 2x minus 4 equals 0. And then I could move everything over to the other side so it looks like x equals a number. My other choice for number 2, if I can't factor it, is to use the quadratic formula. Now this is a bit of overkill if you don't need to use the quadratic formula. This is not your most efficient method. So you won't lose all of the marks if you always use the quadratic formula, but you won't get all of the marks either. So you do need to show me that you can use the more efficient method of factoring when it's plausible. So for example 1, it says to determine the roots. Now you might see that word roots. That means to find the values of x that make the equation true. So determine the roots is just another way of saying solve, which means find the value for x. So in our first equation, x squared plus 4x equals 0, we want to factor this if we can, because it's already set equal to 0, so step 1 has already been done for me. Now when I look at that equation, I notice that there's a common factor on the left-hand side of x. So I'm going to pull that common factor out, and I'm going to divide both of my terms by x. So x squared divided by x gives me x, and 4x divided by x gives me 4. It's a positive 4, of course. Now I have two factors being multiplied together to equal 0. So I've got something times something else equals 0. Now the only way that two numbers being multiplied together will give me 0 is if the first number is equal to 0 or if the second number is equal to 0. So here I can see that the first factor has to equal 0. The first factor is just x. Or the second factor, x plus 4, has to equal 0. Now if x plus 4 is equal to 0, we still have to figure out, well, what's the number for x, or what's the value of x? And in order to do that, I can subtract 4 from both sides of the equal sign, and I see that x would be negative 4. So two solutions there, and I could say, therefore, the roots are negative 4 and 0. We always like to write them in ascending order. So part B, we've got another example here of an equation, and I want to know what's the value from x that would make the left side equal the right side. Now we know step 1 is I have to set it equal to 0 before I can factor. So I'm going to move the 5x and the 3 to the other side of the equal sign, by subtracting them. They're both positive, or they're both being added on the right-hand side, so I subtract them over to the left. Now that that equals 0, I'm going to try to factor this. This is an example of decomposition factoring. So off in my rough space, I'm trying to think of two numbers that have a product of -6. So I took the first number times the last number here. That's how I came up with the -6. And I want them to add to the middle number. So I go through all my possibilities of numbers that multiply to -6. So it could be -1 and +6, -6 and +1, -2 and 3, or 2 and -3. And I can see that the pair I'm going to use is -6 and 1. Now this is decomposition because there's a number in front of the x squared, or a coefficient other than 1. So that tells me I have to decompose or split the -5x into two terms. So I'm still starting with 2x squared. -5x, so will become -6x plus x, and then -3. And you could have written those in the opposite order, that'd be fine as well. Now that I have 4 terms, I'm going to factor them by grouping the first two and grouping the last two. I'm looking for a common factor in each of the groups. So in the first pair, I can see that there's a common factor of 2x, and then I'm left with an x minus 3. Now the second pair is actually already x minus 3, but I have to factor something out of them. I don't want that x minus 3 to change, so the only thing I can divide by and nothing changes is +1. So I am going to divide out a +1, and now that I have those two matching brackets, I'm going to factor them out to the front. They're like a common factor, and I write the leftovers in the second bracket. Again, to find my roots, now that I've got the two factors, I just have to set each factor equal to 0, because I have factor 1 times factor 2 equals 0. Either factor 1 equals 0, or factor 2 equals 0. And then I'll solve each of these equations. So if x minus 3 equals 0, that means that x must be +3. If 2x plus 1 equals 0, that means that 2x must be equal to -1. So I thought about subtracting 1 from both sides of my equation there. And then I'll divide both sides by 2. So I'm left with x is equal to -1/2. And so therefore my roots, or the solutions is another way to say that, are -1/2 and 3. For our next equation, again, I have to set one side equal to 0 before I can get started. So again, I'm going to move that 2 over to the left-hand side. It was a +2, so I'm going to subtract 2. And now I have a simple trinomial here, so I'm asking myself what multiplies to the last number, -2, or sorry, has a product of -2. And a sum, or what adds to the middle number, -6. And I'm going through all the products that give me -2, so it'd be 1 times -2 or -1 times +2, and neither of those add to -6. So this is one of those examples where I need to use the quadratic formula. Remember that your a value is the number in front of the x squared. So I can see that there's a 1 in front of the x squared. Your b value is the number in front of the x term, so that's -6. Don't forget to take the sign with it. And your c value is the constant at the end of your equation, so that's -2. Don't forget your quadratic formula if you've forgotten it. You could go on YouTube and look up a song version of it to help you remember. So x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. And then we'll just substitute in our values. So b is -6, so -b would be +6. And then we've subbed in all the values underneath the square root. And 2 times 1 on the bottom. So I can simplify this, and underneath the square root, I'll get 44. And now I'm going to try to simplify this using my radical rules from yesterday. So I can see that 44, I can make that into a simpler form by writing 44 as a multiple of a perfect square. 44 is the same as 4 times 11, and 4 is a perfect square. That means that I can take the 4 out of the square root. When I do that, I actually have to square root it. So the square root of 4 is 2. And then the 11 stays under the square root. Now on the top, I see that there's a common factor. So I have 6, and then my second term is 2 root 11. The second term might be positive or it might be negative, but that doesn't matter for common factors. So I can take a common factor of 2 out of both of those, and I'll be left with 3, and still the plus or minus. And instead of 2 root 11s, I've divided by 2, so I just have 1 root 11. After I factor, I can cancel common factors from the top and the bottom, just like we did in chapter 2. So I have a 2 on the top and a 2 on the bottom, and I can cancel. That tells me that this is equal to 3 plus or minus the square root of 11. And I'm going to leave it like that. So I'm going to say, therefore, the roots are 3 minus root 11 and 3 plus root 11. I could change that to a decimal, but I really don't need to, and that's just an extra step. If this was a word problem, it might be more useful for me to have a decimal answer. So for instance, if I was solving and x was a time, then I probably wouldn't want to talk about 3 minus root 11 seconds. I would want to change that to a decimal. In this case, though, we want to be as precise as possible because we're still not sure what the application is. I'm going to stop this video now and start a new one for our word problem examples.